If I go to the right, what is my x approaching? Does that make sense? So we have to keep the x versus the y separate. The x always goes, there's always a negative infinity, which is to the left, and there's always a positive infinity, which is to the right. Okay? DJ, as x goes towards negative infinity, what's my y going towards? Okay?
Oh, wait. Positive.
Positive infinity? Which one is it? Positive, positive, positive. Okay? Notice as I go to the left, y goes up towards positive infinity. Lexi, I haven't called on you yet, have I? As x goes to infinity, y goes towards... Alright, does anybody want to push back on any of these answers?
No.
Do we want to ask any questions about any of these answers?
On the last one.
Yeah.
You say x is going to negative infinity.
This one up here, as x goes towards negative infinity. Yes, ma'am?
Yeah, can you label? I know this is negative
So,
and positive, so.
If I'm going to the left, what is x approaching?
So left hand is the top part.
I will say this. If you notice, left hand in behavior, look at all of them. What is x always approaching on the left hand? Negative infinity. Right? Negative infinity is to the left. Right? Because we have this 0 in the middle. Negative numbers are on the left hand side. Positive numbers are on the right hand side. And if it's right hand in behavior, what is x always approaching? Positive infinity. Right? The y is not guaranteed. You have to look at the graph to figure that out. Actually, there is a way to figure it out without the graph. We're just going to focus on the graph. But the left hand in behavior, as x goes to negative infinity, right hand in behavior is as x goes to infinity. Now, Shannon asked the question earlier, well, is it always going to be that case? With the functions we are currently studying, yes. With all functions, no. Because, and let me just give you an example. This is known as a square root function here. Does x approach negative infinity in this function? No. What is the lowest y value, or lowest x value that this function approaches? So when I go to the left, what is the lowest x value? Say it one more time, Shannon. 0. Notice, it's the left hand in behavior. So where's the lowest x value that it goes to? At that origin, as x goes to 0.
I was just thinking if it was balanced, then it would just keep going down.
But even if it keeps going down, you're talking about a y direction. That would still be on the right hand as x goes towards infinity. And it doesn't actually go down, it just slowly rises like that. Okay? That's all it is. Alright, jump to activity 2.1. I just want to go over a couple of key definitions. So that's on M1-212. So what we have here is a polynomial function. It is a function that can be written in this form. Notice there are blanks here. What do you think those blanks are standing for? Numbers, which we call coefficients, right? There's just any coefficient that can go into these boxes. And I know it looks really weird seeing x to the n. Why would we do x to the n? Because it could be any what? Number, right? X to the n, it could be any exponent. Okay? And so we have x to the n plus, and I'll say blank x to the n plus. Notice the very next one is x to the n minus 1 because the exponent has gone down by how much? 1. If we think back to our quadratic that we've done in the past, what was the highest power for a quadratic? So it was ax squared plus bx plus c. What happened to the power every time? It decreased by 1. If I looked at the cubic in standard form, what was the highest power? And what does the exponent do every time? It goes down by 1. Right? And so that's all that we're saying here. I know it's got a variable for the exponent as well, and that's going to freak you out. But all we're saying is that the power decreases by 1 every time. So for a polynomial, and I would make this note here, and it even tells you about the coefficients, right? Notice how it says the exponents are non-negative integers. Right? What's another way we could say non-negative integers? How about the whole numbers? Remember how the whole number set were positive integers? But it could also include 0. So that's all we're saying, is that those exponents have to be whole numbers. Those exponents have to be whole numbers. Okay? And so this is just, I'm introducing this definition of what I mean by a polynomial function. And this is also the standard form of a polynomial function. You think we could have a factored form?
Sure.
Because what is the factored form going to reveal?
Roots.
Roots, right? Zeros, yes, it's going to have those factors, but those factors are dependent upon our roots and our zeros. Okay? So that is something to be aware of. So this is just the standard form. We cannot have a vertex form because there's no real vertex for things higher than a quadratic. Okay? But we can definitely have that factored form. Alright? And so if I ever say quartic, right, not quadratic, but quartic, what power, or what's the degree of the polynomial? 4th. If I ever say quintic, what's the degree? 5th. Right? Degree of 5 or 5th degree. That's just something to be aware of. A quartic is a 4th degree polynomial, while a quintic is a 5th degree polynomial. As far as I'm aware, we don't have names beyond quintic. It's just a degree 6, or degree 7, or degree 8 polynomial. Okay? So, what are the special polynomials that we know? What's the lowest power polynomial? Okay, for a first degree, what kind of function are we talking about if we have a first degree? Say it again, DJ. Linear, right? Y equals mx plus b. That's linear. If it's a first degree polynomial, it's linear. If it's a second degree, it is quadratic. If it's third degree, all right? If it's 4th degree, it's what? 4th degree polynomial? Quartic, right? That's the new one we just talked about. And then if it's a 5th degree, it is quintic. Okay? So those are just the names that we have for those special polynomials. Right? Those are the degrees of them.
There's only 5.
They can go up to degree 6, degree 7, degree 8, whatever you want. But those are the only special names we have. Yeah. Sorry. So yeah, it's just x to the first, x to the second. Technically, we could have a y equals some constant, which is a 0 degree, and we would call that a constant function, but I'm not going to test you on that or anything. Just wanted to round that out. Okay. We are going to get into the last bit of content, or new content. Well, we have one more idea to look at, but this is the last real lesson that has new concepts in it. We will have some practice, and we'll learn one other thing after that practice, because I know y'all need some practice with it. So really quickly, I want you to see here, we need to interpret key characteristics of a polynomial function. What do you think we mean by key characteristics? What are some of the different pieces that we have analyzed about polynomial functions so far? Degree, roots, which degrees are also called, or roots are also called zeros. which if it's on the x-axis, we would call it an x-intercept, right? So we want to talk about the degree, we want to talk about x-intercepts, multiplicity of those roots. What else? Maximum, minimum, domain and range for sure. What is the one we just went over? End behavior, right? Those are those different things that we want to be aware of, that we want to consider every single time. Now, you'll see down here that there are two new terms. Absolute maximum and then absolute minimum. You will not always have an absolute maximum or minimum, but you can have an absolute maximum or minimum. Thank you. Sorry, I forgot to click that earlier. Yes. Okay. Alright. So those are the things to be aware of. And we're going to start with this getting started, right? Math versus the real world. Any of this look familiar? SATs thingy, what did you say? Well, there's an equation with it, but we actually did a unit where we analyzed bivariate data earlier. And then we tried to fit a linear function to the data. Remember when we did regression analysis?
Yeah.
That's all this is, right? We see data here, right? Data was collected. Notice, does that function perfectly hit that data? Every single point? No, gets pretty close. Okay, and so does anyone recognize it says r squared equals 0.9515? It's not exactly the same, but does that look like anything else? Especially maybe if I did a lowercase r?
That's start with C.
It does start with a C.
Correlation.
Correlation coefficient, right? So we want to notice that anytime we are doing regression analysis, we're going to look at a correlation coefficient. There's a reason why it's a capital R, and that's because it's not linear data. That's legitimately all it is. But notice that's r squared. If I want r, I would take the square root of both sides. But I mean, look at it. Is that a pretty high correlation? Yeah. 0.9, remember, is a strong correlation. Notice I didn't say linear because it's not a strong linear relation. What type of relationship is there between the data? Look at the equation that's given to you. So look at the equation. Not additive. Look at this equation. What kind of function would we describe this as? A strong, the highest, or the degree is? Well, the degree is 4, so it's a strong quartic relationship. Right? That is a very strong quartic relationship. Not linear, but quartic this time around. And they did a quartic regression. And if you remember when we looked at the calculators, I think we only did linear regressions, but were there a lot of other options for regression analysis? Yeah, there was exponential, quadratic, cubic, quartic. I think there was a quintic even in there. We don't go much beyond that. Quartic means 4, yeah. 4th degree. So, working within your small groups, right? Think about what is the domain and range of the study. I want you to notice the difference. Part A says what is the domain and range of the study. Part B says what is the domain and range of the what? Of the function. That's talking about the equation that was developed. So talk with your small group. Talk about the domain and range for both of those concepts. I will also point out when we get a little bit later on, and we're actually only going to go through C. You don't have to worry about D through F. But C, it's talking about maximum and minimum, right? So we want to notice those things as well. And so talk with your small group about those. Shouldn't take much more than 10 minutes, hopefully. But talk with each other, help each other get through A through C. So is that the function or is that the
That's the start.
real? So what is the domain of the study? Do you have any data points that low? What is the lowest y value on this in the data?
Alright.
Right, so now.
How about look again?
When the,
You're looking at the graph. Do you have anything else you could look at for the lowest y value? Remember, you have that table as well, right? Doesn't this table have data?
Yeah, but then what would be?
when,
Well, the notice part B is the domain and range of the function.
that's what.
Yeah, so what would be the difference if that's not like?
Well, if we're talking about the study, we're talking about the data points,
And then function would be the function.
the graph stuff.
So I
Yeah.
think the smallest is 108.4.
Smallest one.
The y value.
The domain.
No, the domain is right.
The domain is what?
The domain is
So
right.
what do we say?
I thought you said it was valid.
Oh, what's the domain?
Maybe.
50 to 40.
It does stop, but I want to ask you this, do you even have a data point at x of 50? What's your highest x value that you have in the study?
It'd be zero, what, is there zero?
Maybe.
Zero,
Do you have anywhere else where the data is that you could figure out exactly what the maximum domain value is? So you do have the function, but look again at both pages. Do you have anywhere on both pages where the domain value is?
Zero. Yeah, there's
It's
a
the highest number of months
zero.
that you see.
What's that highest one?
So what would be the maximum for the domain? 43,
402.
right? Because notice the data points don't go all the way to the 50 in the x.
What would be the?
Okay, so for y you got what?
Y is range, right?
Yeah.
So they only collected data from 0 months to 43 months.
That.
I got 108.
So you're correct in interpreting it in context, but have you indicated what the domain and range of this study is yet? So remember, we usually use what notation? So you actually have it for part B, but we need that notation for part A.
So I think that.
So do we need
smallest one like
I would, don't rewrite it. I'm just saying, what is your domain in the study? What is the lowest x value in the study?
Oh,
0.
because it's on the right side.
What is the highest x value?
Is this, I'm so lost, is this, I thought this was
What's
the
the
same thing
difference
as
between the domain and range then?
like
Well,
0 to
the-
18 and
Oh.
19, 20.
Oh, okay, very, okay, got it.
Right? So remember, domain is my x values, what is my range? This needs to be for
Oh,
part
you
A.
mean the smallest?
The lowest is 665, the highest is
That's 11, like for 15, I think it was like 11.3.
900. No, you may be right, I just don't have the 15, 9, 66.9.
Now, domain and range for the function.
Domain
Why do we
is
put
0.
the brackets if this range is?
Brackets mean you can use that.
The function.
Okay, so that's part A, and then you wanna talk about the context of part A. What part B is asking about is for the function in general. Like if you look at that graph, the smooth curve, what is the lowest x value for the
0,
domain?
43, and then 108 and 15. The function is
Listen to the question I asked again. What's the lowest x? Were you going in the next direction? The table.
Oh,
Oh, wait.
Remember, I'm asking about the lowest x. Look at that, look at the curve again. Does it have an arrow at the end? Very much does.
Wouldn't it be positive usually and wouldn't it be negative?
Look again, the fact that close, but remember, lowest would be like the negatives.
Is it negative?
There we go, the lowest x is negative infinity.
So
What's the highest x value?
Negative, whatever this one
That's the domain of the function. Think about your range now. Also, I'll talk about that in a second. That's true for this,
The arrows
of the
are very
function.
both up.
I guess it's not the domain.
Because this is asking about the study. What is the lowest x value in the study?
It would literally just be infinite.
Are we supposed to put that on our A?
Right.
Okay.
Because if you look over here,
Okay.
and you can easily see it here, the x values, the inputs, the lowest x is 0.
Yeah.
What's the highest x value in the study?
And then.
I know for the domain,
Then you
it's
have to
infinite
put these out.
If you look at the x again, what's the highest x value? Right.
That'd be for, yeah.
You can have 0 months, so. Or like negative.
Yeah, no, it can't be negative.
So would it be 0?
Well, no, for
Infinity.
x, like x value would be, or domain, I don't know, cause this little
Yeah.
thing is down under.
That wouldn't affect that, so that wouldn't affect.
Well, remember, so domain is your x values,
It
right?
says.
So what's the range?
Why
The
is
y
that
range.
Study.
Uh-huh.
So, yeah, oh, we're on domain.
So we're supposed to say
Okay,
like,
we had it.
fifth one?
The interval notation always goes from the lowest to the highest. So
I was about to say, how's it not?
what is the lowest y value?
Yeah.
Which one?
Make that negative.
Well, interval notation starts with the lowest, right? So whenever we do interval notation, that's this. You go from the minimum or lowest to the
Yeah, the
highest,
only reason I don't
Every time.
is because there's not arrow going.
right? And so the lowest y value is 108 from 184. And what is the highest y value?
How do you write that? You
The purple dots are the only places that are
Left infinity and right. Well, this
So
one
that's the
is
range,
this
the
way.
lowest y value to the highest y value.
That arrow is kind of.
The interval notation always goes lowest to highest, but then the range is the y. That's what we think. Yeah.
Negative is very, and then positive is very.
In the range of the function.
Well, are you talking about the study, or are you talking about the
That's not
function?
the data thing, so technically
Is this talking about?
that's not saying they are.
So the study is the data that you have. The function is the smooth curve.
Maximum.
Yeah.
So the-
numbers that like.
Would that be a
I don't even know, y'all.
So for B, the maximum y value is what?
I said, I don't know.
So for part B, where it's asking about the function, the maximum y value for the function is
How would y'all know?
Does that
Yeah,
make
y'all
sense?
know.
And then the
You know what I'm
range,
saying? So that means y'all would do too.
infinity, yes.
I know he would.
600.
So domain is your y, range, or sorry, range is your y, domain is your, so, see that arrow?
I don't think.
So it's gonna keep going to the left, isn't it? So what is the lowest x value?
I think it just be infinity,
Right.
that's all you write.
If the study lasted for 15 months, how do you find it?
Yeah, we're about to go over this.
We don't have to do any of the other ones under
Alright, DJ. What did y'all come up with as the domain of the study?
0 with the bracket in front
Okay,
of it. 43.
okay. So why are we putting brackets on those numbers? You can equal those numbers, right? Did anybody come up with a different domain that we want to push back on, or do we all agree on this? We agree? DJ, I may be misremembering, but I don't believe y'all wrote that as your domain at first, did you? What did you originally write your domain as?
Negative infinity, positive infinity.
I thought y'all did 0 to 50 originally, didn't you? And why were y'all thinking 0 to 50?
That's where the graph stops.
That's where the graph, or the x-axis stops, right? But it's important to notice, looking at your graph, that's where the x-axis stops, but is there actual data at the x value of 50? No. Right, so we cannot just look at the x-axis, we have to look at our actual data values. Alright? Group 1, what did you say your range was?
108.4.
108.4 is the lowest y value to a maximum of
15,966.9.
Does anyone want to push back on those numbers, or do we agree with that?
It's not.
I said 66.
66? So I just miswrote it. But does anyone want to disagree with those numbers? Or push back on any of those? We good? Okay, so when they talk about interpreting this, 0 to 43 what? The study, yeah, took place from 0 to 43 months. That's how we would interpret it, putting into context. All of those inputs, they're not just random numbers, they have meaning. So then 108.4 what? To 15,996 what?
Frog thing, or the frog.
What about the frog things?
Frog.
Average number of frog eggs. Okay, so the average number of frog eggs was between 108.4 and 15,966.9. Right? Again, just putting into context, what do I mean by that 108.4 and the 15,000? Oh, I'm talking about the average number of frog eggs. I just looked at the context of the problem. And that's looking at the real world. Okay? So, Kyla, what did y'all say for the domain of B? The domain of the function, not the data, but the function. Okay? Like that? Did you put brackets or parentheses? Okay. So on both of these? Alright. Do we all agree or do we want to push back on any of this? Is it supposed to be parentheses? So what's the difference?
Well, the brackets, then that means you got a back approximation, I think.
Not just that. A bracket means that you can what? Equal it, right? A bracket means you can equal it. Can you ever equal infinity? No, very much no. So we want parentheses here. Anybody want to push back on anything else, or are we good? Okay, so it should be negative infinity to positive infinity? Okay, so why? There we go. It goes, it's always lowest to greatest. Or highest, let's say least to greatest. I like that better. Least to greatest. Kylie, you good with the idea that it's negative infinity up to infinity? Okay? So we want the lowest x value, comma, the highest x value. But I mean, this x stops at 0, so why are you going all the way to negative infinity for the x? The arrow? But this arrow that I see here is going up, so why are you going towards negative infinity? Because it's going to the what? The left, right? Behind the 0. But we want to recognize, and we've got to keep in mind, the domain is talking about my what? X. So it is going to the left, right? The domain is talking about left and right. Remember, the left-hand side is your lowest, right-hand side is your greatest for the x. And then what would the range be? So you think it'd be infinity to negative infinity? Is that what you're saying? Yes? So is infinity my lowest x, or lowest y value?
But no, but I thought it's supposed to, I would know it's gonna be negative infinity.
Okay, so we want to make that range negative infinity up to positive infinity? The arrows are both going up, so it definitely goes towards what? A maximum of positive infinity. But what's the lowest y value? Alright, I'm going to just put my finger along the graph. Tell me when I get to my lowest y value. Right there?
Yeah, and maybe it's a negative.
It is a negative, but does it keep going down to negative infinity?
No, it never.
Right, and that's what we want to be aware of. It doesn't go down to negative infinity, it stops somewhere. Which I will say this, can you look at that graph and tell exactly what it's stopping at? Does anyone know how we could find that minimum though? So we can't look at the or the data because the data is for the study. I want to know what that lowest y value for the graph is. I could graph it, right? Can I type that equation into my calculator and graph it? Don't do that right now because it gets ugly. Just because like you're looking in the thousands, but can you graph that function?
Yeah.
Yes. And then what could you use to help you find the minimum? Menu, and then analyze graph, and then minimum, right? That's exactly what you would want to do. So let's just approximate it for now, maybe negative 3,000 or so. And I would just make a note that's an approximation. Graph to get better answer, right? We're going to skip C for now, sake of time. Okay, but that's approximate, graph to get a better answer. So what we want to really focus on is activity 3.1. Okay. So, may not be where I thought we would be by the end of the week, we'll see. Number one here, use graphing technology to determine the x-intercepts of this function. What do the x-intercepts mean in the context of the problem situation? Actually, let's do this really quickly. We're going to skip 3 anyways. I want to talk about 4 because this idea of increasing, decreasing, we'll go back to number 1 and 2, so remind me of that tomorrow. When we talk about increasing and decreasing, I'm going to go ahead and define this because we haven't seen this show up yet. What I am talking about is I am looking for a domain interval. So when I write the interval, what numbers am I going to be putting in that interval notation? X values. Domain is my X. But I'm looking for a domain interval for which the function increases. I want you to think about this graph. We always read a graph the same way we read a book, from left to right. If I'm reading from left to right, the x value is always what?
Teachers and students, please pardon the interruption, but when the bell rings to go to second block, I need to see the following people in front of the office, please. Eliza Coleman, David Coleman, Andrew Chanel, Jacquez Connor, James Duffy, Gerald Fritz, Trey Gurley, Devin Hunter, Parson Hurst, David James, Coco Kaiser, Javon Madison, Micaiah Holmes,